Why does this query takes over 2 seconds while this one executes instantly? Well, if you said that's because of the additional column that the above query has to process, you are about 20% right. And by watching this video, you are going to understand the remaining factors that make select static slower and how you can address those to make your queries faster than ever. You must have heard that select static is slower than selecting only the columns that you need. And it seems that it's true, comparing the performance of these two queries. But is this because only of the additional columns that select static has to process? We're going to find out soon enough. Everyone understands that query 1 is slower because we simply have more data to move around. We need to read more bytes from the disk, we have more data to serialize, we have more data to send over the network, and therefore the query 1 is going to be slower. However, modern servers are very good, and I mean really truly very good at moving bytes around. They are so fast that if you take 500 bytes and then you take maybe around 50,000 bytes and you try to transfer them, one is probably going to take a few microseconds, and the second might take a few hundred microseconds. But the user is only going to care when maybe your query takes over a few hundred milliseconds, at least a few thousand times more than using select static can incur on your query. However, by using select static, we aren't just making a query slower because of more data. We are incurring another cost that most people don't know about. Before we move on to that, let's see that in practice. I'm going to use this to enable stats. And this is going to tell us the time a query takes to execute and the number of reads it performs on our actual disk. So by running that, we're enabling statics. And now I am going to run query number 1. And we can look in the messages here. And here we can see that within table orders, we performed 55,337 logical reads and 0 physical reads. And by physical reads, we mean that the data wasn't available and therefore we had to go and check. Sorry, by physical reads, that means that the data wasn't available in our cache and therefore we had to go and check the disk itself, the hardware disk for that data. And by logical reads, SQL Server already has that data available and it simply use that data from cache, which is much faster than using the disk itself. But whether we have logical or physical reads, reads are reads. More reads means more time. Therefore, if I run the second query and look within messages, it only has 175 reads. And it doesn't make sense because the second query has two columns and the first query has 5 columns. Or in other words, we should have approximately 2.5 times more reads than this second query here. But if we calculate, we have 55,000 reads and then we have 175 reads. And 55,000 divided by 175 is, it's more than 100. It's very much more than 100. The point is, even though we have only added 3 more columns, our query is running at least 400 times slower than if we hadn't added those columns. And why is that? So SQL Server has that thing called indexes, and if you don't know about that, here's a video for you that you can watch to learn more. But for now, I'm just going to explain it in a simple manner. I'm going to enable something called execution plans from here. And now that I execute my query, we have another tab here. It's going to be added in a moment. There we have it. And you can see that it performs a clustered index scan. And whenever you see an index scan, SQL Server is reading your entire table. And when you see a clustered index scan, SQL Server is reading all columns from your table. If you have a non-clustered index scan, SQL Server might be reading a few columns. It might not be reading all columns from your table. But a clustered index scan means all columns. If you see an index seek, that's much better news because SQL Server is taking a shortcuts, is only taking the rows that you need instead of reading everything from your table. And by that clustered index scan, we can see that it's using a clustered index scan, then it's combining all those rows and then it's picking the top rows and then selecting them. But if I use that second query, we have a non-clustered index seek, and like I said, non-clustered index seek or even clustered index seek is very good news. That means that SQL Server is taking shortcuts, and by taking shortcuts the query is getting faster. So why couldn't it take the same shortcut here? Well, we have an index on that status column. That means that whenever we use that status column within a filter, SQL Server is going to take the shortcut. But once we add all these columns within our select, that means that all the columns that we're going to select must be within that index. And we don't have all those columns within that index. In fact, we actually have two columns, status and created at. And every index in SQL Server automatically has the primary key column. So if I add created at here, this is still going to be at least 100 times faster than the query above. If you go here, there are still only 175 reads. That means that by adding one more column, if I add customer ID for example, and then execute that again, our query has gotten slower. And that's because that status index that we have doesn't have that customer ID column. And therefore, it has to go back to scanning the entire table, reading every row, wondering whether it has status equals to pending or not, and making a query slower. So by selecting more columns, you have more data to move around, but there's just a teeny tiny bit of more computing to do. But the index, that index that you are not using anymore is a huge penalty that SQL Server is applying on every row, on every query that you are executing, and in fact it's more than 99% of the cost that you incur by using select static. Now here's the third and the last type of cost that you incur by using select static, and it has to do with moving more data around. The thing is, while SQL Server itself is very good at moving things around, not everything around it is. When you read the data from SQL Server, if you get more data, you need to move that to your app servers. From there, they're going to be moved to your services, and from there, they need to move over a DNS to your client's computer. And then at your client's computer, you might run some JavaScript to process that and display that in a table. And at every step, that additional data is being carried around redundantly. And every computer, every machine in the way is usually not a server designed to move data around. Your client's computer is just a desktop, maybe it's a mobile device that you're using. You're going to send more data there, and it's going to make your client's device slower. And they're going to blame your website because really your website is making their device slower. SQL Server itself is very fast in reading thousands of kilobytes, even gigabytes of data and then sending it to your website or to your web service. But your server isn't designed to do that. It's designed to serve thousands of clients simultaneously, but it's certainly not designed to serve thousands of gigabytes of data around that most of your clients don't need. In reality, SQL Server isn't being disturbed by that extra data. It's being disturbed by indexes, of course, but your network, your bandwidth, your client's computer, your DNS, your proxy, all those are the ones serving all this redundant data and getting disturbed, not SQL Server. And in reality, that cost is much larger than SQL Server actually incurs. Now, here's the final issue caused by select static, which doesn't impact performance, it impacts something much worse. Have you ever, while working in SQL Server, selected from a view and just tried to inspect a column by scrolling through thousands of columns and finding the exact one that you need? I have. I have scrolled through over 100 columns selected by a procedure, and obviously that's a procedure. You can't just select a specific column from that, and you don't want to change that procedure. Similarly, you might have seen reports where the query simply spits out like 500 columns and you have no idea what each of these columns is supposed to do. Select static impacts developers' performance, and developers' performance costs much more than SQL Server's performance. If your developers are working slower because they can't find the columns they need to, they can't figure out what each column is there for, you are incurring a cost much higher than what SQL Server can cost you. And by selecting the columns that you need, by only picking the data that you need, and by supplying that data only, you're supplying every future developer with something that they can actually use. All of them are going to thank you, believe me.